Okay, this is lesson 2.8, page 103 in your algebra book. And this is a hot air balloon. And this is a creepy looking hot air balloon because it reminds me of a controversy that we had in my family at Christmas time, because my sister, when she was little, had this creepy nightlight that was in her room, and I'm going to show you a picture of it in a minute. The one in this one has red eyes, but hers had blue eyes, and so at night all you would see with these two blue eyes looking at you. It was really freaky. This lesson, though, relates back to lesson 2.5, where we talked about the downward displacement that we measure. It's measured by a negative number. I don't know if you remember that lesson. And so we're going to come back to that in just a second. But you can look at my creepy nightlight here. My sister's creepy nightlight. So here it is, except that the eyeballs were blue, and that's what would shine when you did that. Anyhow, you gotta admit, it looks like that hot air balloon. You can see how I got distracted, right? You'll be able to hear my cat purring because it's literally, the mouth of my cat is literally right over my iPad. So we'll see how this goes. Two numbers whose product equals 1 are called reciprocals. For instance, here, let me fix this right here because this should be negative 2 over 5 and negative 5 over 2 equals 1. Okay, is going to equal 1. Okay, so we have a new property to learn about. This is called the inverse property of multiplication. And basically, for every non-zero number a, there is a unique number, 1 over a, such that a times 1 over a equals 1, and 1 over a times a equals 1. I mean, we just move it around with the same thing. Now, there's a division rule, so we have the inverse property of multiplication, and now we have a division rule. And basically, to divide a by a non-zero number b, you multiply a by the reciprocal of b, and the result is going to be the quotient of a and b. I know. So it's kind of confusing, but let me show you now on the next screen what I mean. Okay, so example is a divided by b equals a times 1 over b. So in our example here, we have negative 1 divided by 3. We can rewrite that as saying negative 1 times 1 over 3. So we've done this part and we've done this part. And then the result is going to be negative, I keep doing this. This is not negative 1 right here. It's for the whole thing. Negative 1 over 3. Sorry about that. It's too late. I can't fix it, so just take my word for it. The negative goes there. Okay, so let's look at some examples. On first example A, we have 10 divided by negative 2, and we rewrite that to be 10 times negative 1 over 2, and then the answer is negative 5. In our example B, we have 0 divided by 5 over 7. We're going to rewrite that to be 0 times 7 over 5. So we have the reciprocal, and of course then that will equal 0. Now for C, we have negative 39 divided by negative 4 and 1/3. Well, first of all, we notice that we have a mixed number here, and we want to turn it into an improper fraction. Okay, so this one we have, this is what I was talking about before. You have the mixed number right here. We turn it into an improper fraction. We have 12 plus 1 is 13. So we have negative 39 divided by negative 13 over 3. We then multiply 39 by negative 3, and we get 117 divided by 13, and then you're going to end up with 9. Now we're going to talk about how you would simplify complex fractions, knowing what we know now about the properties. In this example, we have negative 1/3 divided by, over 4, which someone might say, ooh, wow, that's kind of hard, but it's just a division, so we rewrite it as negative 1/3 divided by 4. Now, because we have the negative 1/3, we know that we need to use the reciprocal, so we have negative 1/3 times 1/4, and then that's very easy to multiply out, and we end up with negative 1/2. Not so hard. Okay, in this case, we have 1 over negative 3/4. We rewrite that into a division. We have 1 divided by negative 3/4. That's going to equal, we're going to use the reciprocal, so 1 times negative 4 over 3, and 1 times anything is just going to give us negative 3/4. Now we know that the quotient of something, the quotient equals the dividend, I better write that out, the dividend over the divisor. We can also check, let me rewrite. We can also check our solution by doing the quotient times the divisor, and it should equal the dividend. So in that case, we have negative 4 over 3. We can times that by the divisor, which is negative 3 over 4, and that would equal 1. So we know that we did it right. So that's just a little check you can do. Okay, so let's talk about dividing real numbers and finding the quotient. So if you had this problem, 8 divided by negative 4, the answer is going to be negative 2. You might ask, why? And so we go to the sign of the quotient rule, and we have, for example, negative a divided by negative b equals a divided by b, which equals a over b. So if you have two negatives, the answer is going to be a positive, just like in multiplication. If you have one negative and one positive, negative a divided by b equals same thing as a divided by negative b equals negative a over b. And in real life, that looks like for example, negative 20 divided by 5 equals negative 4. One negative, one negative. 20, or it's the same thing as it's 20 divided by negative 5 equals negative 4. So the sign of the quotient rule is going to be two positives equal a positive, one negative equals a negative when they have opposites. So here's another example. Negative 5 divided by negative 2 and 1/2 equals, okay, so we have two negatives here, so we know the answer is going to be positive, and so we can quickly solve this. We're going to, the reciprocal of this would be 5 over 2, well, not the reciprocal. We make this an improper fraction, and then I turn it into reciprocal. We have 10 divided by 5 equals 2. We already know the sign is positive. We have another example here. We have 3 divided by negative 3 over 4. And so we can work that out. We know we just have one sign here, so we're going to have a negative answer. We let's see what we get when we work that out. 3. I'll use the reciprocal here. End up with 3 into 12. We have the negative, so we're going to end up with negative 4 on that. Here we want to look at evaluating an expression. We have negative 2a over a plus b when a equals negative 2 and b equals negative 3. So we replace what we have. We'll have negative 2 times negative 2 over negative 2 plus negative 3. We will simplify this. We're going to end up with 4 because we had 2 positives there. This is a plus. We're going to have negative 5 there. And the quotient of two numbers with opposite signs is always negative. So our answer is negative 4 over 5. Okay, so next let's work on simplifying an expression. In this case, we have 32x minus 8 over 4. We can rewrite that into an expression. We have 32x minus 8 divided by 4. I've just rewritten it. And I can rewrite it again as 32x minus 8 times the reciprocal of the 4. I can rewrite it again as 32x times 1/4 minus 8 times 1/4. Okay, and then I can use the distributive property here and rewrite this because we're basically dividing both the 32x and the 8 by 4. So we can distribute that 1/4, the reciprocal there, as 32x times 1/4 minus 8 over 1/4. And our answer would be, when we work it out, 8x minus 2. So in this case, we're going to evaluate and simplify expressions. The first thing we want to do is evaluate. So here we have negative y over 2x plus 1 when x equals 2 and y equals negative 5. So when I replace the x equals 2 and the y equals negative 5, I'm going to get a 5 over 2 times 2 plus 1, which is 5 over 5, and we end up with 1. Next, we want to simplify it, like I said, the 24 minus 8x over 4. We end up with negative 6 plus 2x on that one. Okay. So make a note here, because you're going to be asked to find the domain of a function. When a function is defined by an equation, its domain is restricted to real numbers for which the function can be evaluated. It's important to note that division by 0 does not equal a real number. Okay? Thus, when you're doing input values that result in a denominator equal to 0, those numbers are not in the domain. So just remember that. So let's go through how you'd find the domain of a function with y equals negative x over 1 over x. This is, I didn't have enough room here, so bear with me. Don't do it this messy on your paper because I'll take off, but this is the best I could do here. So our input, we have x equals, we'll try it with negative 1. And when we substitute in the negative 1 here and here, here and here, then we would have negative times a negative, and 1 minus negative 1. Then that equals y equals 1 over 2. The second one, we have y equals 0, and that example is negative 0 over 1 minus 0, where y equals 0. This one is the tricky one. X equals 1, because when we do 1, we have negative 1 over 1 minus 0, and that makes it undefined. So it's not in the domain of the function, because you can't divide by 0, because that would be 1 minus 1. Okay, I'm back. I hope never mind, I don't know. And then the next example was x equals 2, and that solution is x equal to negative 2 over 1 minus 2. So if we were to answer this correctly, we would say that the domain is all real numbers except x equals 1 in this particular case. And you've done domains before, so you just have to set it up, input, substitute in, and then what's that? Okay, so I had to restart this. What we want to do is look at some examples and figure out what are real values and what are ones that won't work. And they won't work because the denominator is going to be equal to 0, and that would mean that that number isn't in the domain. So looking at this one, let's take this example. We have y equals 2x and x minus 2. We could go through a whole array of numbers, but let's try 2. Let's say we worked our way through 1, 2. We get to 2. We would have 2 times 2, 2 minus 2. Well, right now we see we're going to have a problem because that's going to be 0. So in this case, I would have all would be real except x equals 2, okay, because we can't have that. Same as here, I could have x equals 7 over 8 minus x. I could go through again a whole bunch of values, sample values, but when I get to 7 to 8, and I input the 8 here, again I'm going to end up with 0. So again, all would be real except 8. In this one I have y equals 5x over 2, and I get all reals. On this one, didn't get one that would be 0, so on this one x equals 10 over x, I'm going to have all reals except when x equals 0. So that gives you, when you're finding the domain of a function, you don't want the denominator to be by 0 because you can't divide by 0. If you're having problems with the domain of a function, go to the Khan Academy and type in domain of a function and watch their video. It'll help you if you're still confused. I don't have enough time here to go into details, but I can do it at a later date. But if you need some help with that, go to the Khan Academy and look at their lesson. 0. Oh, I don't know why. Okay, your assignment for 2.8 is page 116 and through to 118. It's numbers 27 through 30, 37, 38, 40 through 52, 53 through 55, 59 through 61, 63, 68 through 70, 75 through 78, and on quiz 3, do problems 10 through 21. And I went through all of the different kinds of problems, so you may have to refer back to my different the different pages here to be able to, if you need some help. Good luck.